Alright guys, so we're going to go through finding the measures of angles and solving for x and y when we have congruent triangles, and we're going to incorporate systems of equations in that. So in this triangle here, we have triangle ABC is congruent to triangle DEF. So angle A equals angle D, angle B equals angle E, and since those two angles have to equal, C and F also have to equal. Alright, if two angles are congruent, the third angles have to be congruent. And by this congruency statement, all the angles have to be congruent anyway. But if you notice, angle A and angle D sets up 8x plus 8 equals 3y plus 21. Angle E and angle B being equal sets up 16x minus 9 equals 8y minus 1. So when this happens, we need to get the y's and the x's on one side and the numbers on the other. I subtract y and I subtract 8. I subtract my 8y over here, I add my 9 over here, and we end up with 8x minus 3y equals 13, 16x minus 8y equals 8. So once again, if you notice, I moved my 3y over, I moved my 8 over. I moved my 8y over, I moved my negative 9 over. Right? And now we have a system. If I multiply the top by negative 2, I get negative 16x plus 6y equals negative 26. Below, I get 16x minus 8y equals 8. The 16x's cancel out. We're left with negative 2y equals negative 18 and y equals 9. Plug 9 back into 8x minus 3y equals 13. I solve for x and I get my x equals 5. It works the same for sides. If we have congruent triangles, ABC and DEF, the corresponding sides have to be congruent. AB matches up with DE, AC matches up with DF. So 4x plus 1 equals 2y minus 5, and 5x plus 2 equals 2y minus 2. We need to move the 2y over, move the 1 over. Move the 2y over, move the 2 over. And we're left with 4x minus 2y equals negative 6, and 5x minus 2y equals negative 4. When I multiply the top by negative 1, I get negative 4x plus 2y equals 6. And that allows me to eliminate the y. And I'm left with x equals 2. I plug the 2 back into an original. 4 times 2 minus 2y equals negative 6. Go through the algebra, and you're going to get y equals 7.